All right, so this is it for our series on sequences and series. We have talked about all the stuff we need to know about sequences, and we've basically talked about everything we need to know about series. This video is just simply going to provide some examples of how to use the formula to calculate the sum of a geometric series. So if you haven't already watched that first video, you may want to go back and do that. If you have watched it, then you'll remember this was our learning objective. Simply find the sum. And to do that, we talked about using this formula right here. So if you haven't watched this video, you might want to go back and watch that. But if so, then we're going to pick it up using this formula to find the sum of this geometric series. Okay. As a reminder, I know it's geometric because I have an exponential looking thing. That is an important part. You want to check that. If it's not exponential, you don't want to accidentally use the geometric formula. You want to make sure you're using the arithmetic formula. Okay, so make sure you're using the correct formula depending on what type of sequence you have. All right, so as you know, because we've been together for a while now, I like to set up my formula off to the side with a little bit of scratch paper and stuff just to make sure that I remember all the things I need to calculate. So I'm going to need to calculate what my first term is. And then I will multiply that by the common ratio. The common ratio I won't need to multiply. Remember, that's right in my formula. I just have to remember how to find it. So the common ratio raised to the number of terms, that I'm going to have to figure out, minus 1 over the common ratio minus 1. So that was our formula. That's how we find the sum. This whole thing is equal to the sum. So that's what we're doing. And to find the first term, remember, I'm going to take my formula here. And where k is, I'm going to plug my first number in. Okay. Now, I want to just make sure that we're clear on this because we've done this now for a couple of videos. First term is different than term number 1. This is term number 1. If I were to plug a 1 in for k, the answer I would get is 12. But in this series, my first term is term number 4. So even though term number 1 is 12, that's not what I'm looking for here. 12 is the number 1 term in the sequence. But I want the first term of the series, and that's what I'm going to find when I plug in 4. So I'm going to plug a 4 in for k, and then I'm going to simplify this. So 4 minus 1 is equal to 3. 4 minus 1 equals 3. 1/2 raised to the third power, that's going to equal 1/8. And then 1/8 times 12, I believe we're going to get 3/2. Let's make sure. Indeed, 3/2. So you can write it as a decimal, or you can write it as a fraction. Remember, we've talked about that often in these types of problems, fractions are a little bit easier to work with. Okay, so maybe I want to write it as my fraction 3/2. Okay, so I've got that. Now, r is just the number in my parentheses, the number that has the exponent. So r is 1/2. And then that just leaves n. And for n, we said you can count if it's obvious to you. In this one, it might be obvious. If it's not obvious, then you can use a little formula. But this one, notice, if the first number I plug in is 4, and then I plug in a 5, and the last number I plug in is a 6, n is going to be equal to 3, right? There's going to be 3 terms. But I can also calculate that. 6 minus 4 equals 2, and then plus 1 would give me 3. So n is going to be equal to 3, right? So there's all the facts that we need to calculate the sum. So this sum is going to be equal to our first term, 3/2, times the common ratio, 1/2, raised to the number of terms power, 3, minus 1 over 1/2 minus 1. Okay, so now we just go through and we simplify. You can simplify it with order of operations, and I did that in the last video. But I think for this video, just to show an alternative, I think what I'd like to do in this video is go ahead and type it all in as it's written by taking advantage of the fraction feature, right? Remember, if you push alpha y equals, you can make fractions. And so if I choose that, I can type in my 3 over 2. And then I can put that first great big parenthesis. And now I can put a fraction inside of that parenthesis. In the top, I'm going to put another fraction. Whoops, what happened there? Alpha y equals, there we go. I'm going to put another fraction in the top for the 1/2. I'm having trouble pushing the right buttons. There we go. Now I'm going to take that and raise it to the 3rd power. Then I'm going to subtract 1 from that answer. And that's my top. In the bottom, I'm going to, again, put a fraction. 1/2. And then I'll subtract 1 from that in the bottom. Then that whole great big fraction is in parentheses, and I can calculate my answer. And again, you can write your answer as a decimal or as a fraction. It's up to you which way you prefer. Okay, so in this case, we end up with a final answer of 21/8. Now, again, I chose to type that all in as one great big fraction. And you can do that if you want to using the alpha y equals button. Or like we did in the last video, you can use order of operations to figure this out piece by piece. All right, so there's our first example. And let's do a second and final example. Now, just like I've been doing in the other videos, if you are feeling up to speed, I would encourage you to pause this and try this on your own first. All right, so give that a try. And then after you've had a chance to find that answer or figure out where you're getting stuck, whichever one comes first, then resume the video and you can compare your work with my work. All right, so hopefully you've given this a try. As you know, I'm going to start with my formula that the sum is equal to the first term of the series times r to the n over r. There we go. Okay, I didn't quite say all that. R to the n minus 1 over r to the 1 minus 1. Okay, so I need to find my first term. My first term is what I'm going to get when I plug a 3 in for j. So I'm going to have this times 3 to the 3 minus 1 power. And since I'm not real good with my dividing by 54s, I don't know those times tables very well, I'm just going to type this one into my calculator. So 1 over 54, and then times 3 raised to the 3 minus 1 power. And it looks like I get this big funky decimal. Now, one word of caution, if you choose to write your answer as a decimal, that's fine. But remember from our discussions early in the year, don't round this off, right? You don't want to round off till you get to your final answer, or you're going to end up with a wrong answer. If I switch it to a fraction, it's a very nice fraction. That's 1/6. I know it's a little hard to see on the screen there, but that's 1/6. So I'm going to write it as a fraction because I think 1/6 is a whole lot easier to write than that great big decimal. Okay, so there's my 1/6. So that's my first term. Then I need to find r. R is pretty easy. It's just the number in the parentheses that has the exponent. So r equals 3. And then I need to find the number of terms. Okay. And again, you might be able to count this. If I start at 3 and I go to 7, I might be able to count that out and figure it out. In this case, though, it's a big enough gap that I'm going to actually do my little formula. Top number minus bottom number plus 1. So 7 minus 3, that equals 4 plus 1. I'm going to have 5 terms altogether. Okay, so now I'm ready to plug these things into my formula. So this sum will be equal to the first term, which is 1/6, times r, which is 3, raised to the n, which is 5, minus 1 power, over r, which is 3, minus 1. So there is my fraction. And since I did this last one by typing the whole dealie in, I'll do this one with order of operations so that we can kind of see the difference. So the first thing I'm going to do is 3 to the 5th power. 3 to the 5th power is equal to 243. So 243. And then I'm going to subtract. And this one, I'm going to go ahead and subtract the top and the bottom both, just because that's fairly easy math. So when I do the top, I'm going to get 242. When I do the bottom, I'm going to get 2. So I subtract those. And now I can divide 242 divided by 2. That's going to be equal to 121. And then I can multiply 121 by 1/6. And it looks like I'm going to get a fraction for this. Again, you can write it as a decimal. Since this is my final answer, it would be okay to round this off to like 20.2. You could put 20.166 with the 6 repeating, or you can switch it into a fraction. And notice that as a fraction, it doesn't even really simplify. It's just 121 over 6. Okay, so whichever way you want to write that is fine. It really doesn't matter to me which way you choose to write it. But we should all end up with an answer that looks like something that I've got here. Okay, so that's it for this video. Thanks for watching. Have a good one.